Hello students, welcome back. In this video, I am going to solve exercise 1.3 of NCERT textbook, and before starting this exercise, I am going to explain the concept which is required to solve the questions of this exercise. So let's start. What is a subset? A set A is said to be a subset of a set B if every element of A is also an element of B. So this thing we will understand with the help of an example. So I have given here one example. So here I have one set A. So elements of A are 1 to 5. All natural numbers still 5. 1, 2, 3, 4 and 5. And elements of B I have all natural numbers still 10. And here we can see that A has 1 also. B also has 1. A has 2. 2 is there in set B also. Similarly, 3, 4 and 5 are also there in set B. So we can see every element of A is also an element of B, which means A is a subset of B. Which means A is a subset of B. See, I cannot write that B is a subset of A because B is a greater set. Subset means set A is contained in set B. Like suppose if this is set B. Suppose if this is set B. So here A is contained. This is set B and this is set A. So like this you have to understand. Subset means that particular set is contained in the bigger set. So this is the meaning of subset. Now we'll take another example. So example number second I have given. A is 1, 3, 5 and B is equals to x such that x is a odd natural number less than 6. That means if I have to write it in roster form, it will be 1, 3 and 5 because odd natural number less than 6 is 1, 3 and 5. So here I can see A, every element of A is also an element of B. So which means A is a subset of B. See, every element of A, 1 is there in A as well as in B. Similarly, 3 is there in A, also in B also. Same way, 5 is also present in both A and B. So every element of A is there in set B also, which means A is a subset of B. Same way, every element of B is there in set A also. So I can also write it as B is a subset of A. So when two sets are equal, see it's clearly visible here that set A is equals to set B. See when two sets are equals to each other, that means both the sets are subsets of each other. So you can see I am writing one symbol like this. This symbol is a symbol of subset. And in exercise 1, we have learnt this symbol. This symbol means belongs to. So this subset and this belongs to. Like you can see I have written here A is a subset of B. Whenever small a belongs to capital A, then the small a will also belongs to capital B. Now let's see one note. See if two sets A and B such that A is a subset of B. So two sets are there and one set is a subset of other set and both the sets are not equals to each other. Then A is called proper subset of B and B is called superset of A. So this thing, see here from examples we'll understand. I have discussed two examples. In first example, A is a subset of set B. So I have shown you figure like this. Suppose this is a set B and here we have another set A because set A was smaller set. So both the sets are not equal. See A is 1, 2, 3, 4, 5 and B is 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So A is contained in B because every element of A is there. Every element of A is also an element of B. That means A is a subset. See in this case both the sets are not equal. So here A is proper subset of B. Here A is proper subset of B and B is called as superset of A. So A is proper subset, B is superset of A. This is when A is not equals to B. See, when A is equals to B, that case we have already discussed. In that case, both the sets will be subset of each other. So when A is equals to B, in that case, A is a subset of B and B is a subset of A. So next concept, let's move further. So next concept is of power set. Now what is the meaning of power set? The collection of all subsets of a set A is called the power set. So collection of all subsets, it is denoted by PA. It is denoted by PA, and in PA every element is a set. So I've taken one example. With the help of example we'll understand. See, if we have any set A, so any set A is there. I've taken this example. So set A has elements 1 and 2. So first of all we will write its subsets. So regarding subset, you have to understand one thing. Empty set 5 we have discussed in previous exercise. So this 5 denotes empty set. See, empty set will always be a subset of any set. This is very important thing. And second thing regarding subset is that a set itself. So now A is this. This will also be a subset of itself. So two subsets will always be there. First is empty set and the other set is set itself. So these two sets will be subsets of itself always. Other than that, if I have this set, so one singleton sets, since when set has only one element, that set is known as singleton set, singleton set. If a set has only one element, then that particular set is known as singleton set. So when I am writing all the subsets, so all the subsets means every possibility I have to write. So subsets of A will be, first of all, 5 I have told you. Then 1 will also be a subset. Then 2 will also be a subset. And A itself. A itself means 1 comma 2. This is also a subset. So power set will have all this. See, power set of A is, so because it's a set, we have to write it in curly braces. See, I have already written. Then inside this power set, every element is a set. See, 5 is a set, empty set. This is also set. This is also set. This is also a set. I'll give you one another example. So suppose I have any set A. So A, I am taking it as 1, 3, 5. Now it has 3 elements. So I have to write its power set. For power set, I need all the subsets. So let's write all the subsets. So as I have told you, empty set will always be a subset and set itself will always be a subset of itself. Now remaining, so 1, 3, 5 individually we can write 1 as a singleton set, 1, then 3 and then 5, and then they can be written as together 2 2 also, like 1 3 3 5 and 1 5. That's it, because 1 3 5 is A itself, so I have taken that as well. So here these are all the subsets. So if I have to write power set, so power set will be P of A. So inside curly braces I have to write all this set. So it will be 5. 5 means empty set. Set A. A also you can write, or you can write in this way also. Then singleton set 1, 3, 5, 1 comma 3, 3 comma 5 and 1 comma 5, and this closed. So this is the power set of this set A. So now very important thing, first of all, see how many elements are there in this set. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. See, 8 elements are there. This number of elements easily we can calculate also. So we can use this formula, number of elements of power set is equal to 2 raised to power m, where m is the number of elements in the given set. Now I have given you two examples. So first example was this one. So here A has how many elements? A has two elements. Okay, so M is equal to 2 here. So if I have to find its number of elements of its power set, number of elements of its power set, so it is 2 raised to power M. So that means 2 raised to power 2. So 2 raised to power 2 means 4. Now this example I have taken, so we can see here 4 elements are there in the power set of this set A. 1, 2, 3, 4. Now this one, next one I'll see. We will see now this A has how many elements? The example which I have given here, this A has 3 elements. So that means M is equals to 3 in this case. So its power set will have how many elements? 2 raised to power M, which means 2 raised to power 3, which is 2 into 2 into 2, which is 8. And we can see here its power set has how many elements? 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements are there in the power set of this set A. Now let's discuss the other next topic, so which is universal set. So I hope you have understood the meaning of power set. Power set is all the collection of all the subsets of set A. Now next is universal set. Universal set is denoted by U. So with capital U we always write it. It's a set which has elements of all the related set without any repetition of elements. So what is the meaning of this? One example I have given here. So I have given one set. Set A is there. So A is 1, comma 2, comma 3, and I have another set B also. B is 1, A, B, C. So here for these two sets, I have one universal set which is 1, 2, 3, 4, A, B, and C. See, from this set itself, I can take A set which is equals to 1, 2, 3, and from this set U I have taken another set B also, which is 1, comma A, comma B, comma C. So that means universal set is that particular set from which we can take any other set. Like with the help of another example we will understand. Also you have to remember, if any set is a universal set, so other small sets will be subset of this set. So here A is a subset of universal set, B is also subset of universal set. I can take many other sets from this one. I can take set C also, 1, comma A. I can take some set D also, B, comma C. So like this, many sets can be taken from this universal set. Another example from maths I will take. Suppose I have set of real numbers. Suppose I have set of real numbers. So real numbers, with the help of diagram, this Venn diagrams we will actually do in next exercise, but here I will just give you a small introduction of this. Suppose this is one set, and this set is a set of real numbers. So here I am taking another set. Suppose this set I am taking, this set is a set of natural numbers. Again I am taking another set. So the set I am taking from this one, let's say integers. Okay, so now for natural numbers and for integers, R will act as a universal set. This goes with set of even number, even integers also, for rational number also. So if these sets I'm taking, if I'm taking a set of natural number, set of integers or set of even integers or set of rational numbers. For all these sets, R will act as a universal set. So universal set is a bigger set. It's a bigger set from which small sets we can take, like the example I've shown you. And mostly the students will get confused between power set and universal set. See, power set is not the bigger set from which we are taking other sets. Power set is just collection of all the subsets. So both the things are different. I hope you have understood the difference between these two. So power set is collection of all the subsets of A, and universal set, in very simple words I will explain. Universal set is a bigger set from which we are taking numerous smaller sets. Like here I have given you this example of real numbers. Now let's move towards the next topic, and moreover when we will do questions of this exercise you will have a clear picture of all these concepts. So next topic is intervals as a subset. Now what is the meaning of this intervals? See, intervals means, one example I'll take, I'll write 2 comma 3. So this is one interval. So what does it mean? It means collection of all the numbers. See, this is one interval. This is a way of writing interval. And intervals are always subsets of real numbers. So why subsets of real numbers? That also I'll explain. See, if I'm taking this interval 2 comma 3, it means all the numbers or collection of all the numbers. So collection of all the numbers between 2 and 3. Between 2 and 3 means here we are not including 2 and 3. So this collection will start from here, like 2.1, 2.03, 2.004, 3.0 point, not 0 point, it will be like 2.5. So all the numbers, so numerous, infinite numbers will be there. All the numbers between 2 and 3. Okay, so we don't have to include 2 and 3 in this one. So this is known as interval. So this interval, why it is a subset of real numbers? Because all the real numbers are very big. Real numbers from positive infinity to minus infinity they'll go. This means real numbers. Negative infinity to positive, if I see with the number line. So these are real numbers. So this is just a part of this. If this is a number line, every number on a number line is a real number. So this I am taking a number line. So 2 to 3 means just a part of this one. This one. Real real numbers are every numbers on this number line. So part of this is this interval 2 comma 3. So for this reason, because this interval is contained in real number, so that is why this is a subset of R. Now here we'll understand one thing. When I'm writing the interval like this 2 comma 3, this means open interval. In open interval, endpoints like 2 and 3, they are not included. I can write interval like this also, 2 comma 3. This means closed interval. See, square brackets here I have written. So this interval is closed interval, and in closed interval 2 and 3 they are also included. So we have some another type of intervals also, closed 2 and open 3. This means 2 is included, 3 is not included. Also open 2 and closed 3. That means 2 is not included and 3 is included. So same thing I have written here also. Let AB belongs to real numbers and A is less than. So you can compare, A is less than, 2 is less than 3. Then the set of real numbers. So real numbers where Y, such that Y is greater than A and less than B, is called open interval. Same thing I have explained you. This interval is known as open interval, and it is denoted like this. All the points between A and B belong to this, but A and B they themselves do not belong to this interval. Now the next Next, also I've already discussed this is closed interval. So this closed interval, these 2 points are also included. So these are the other intervals, and intervals are always the subsets of real numbers. So that's also I've explained you why these are the subsets, because they are contained in all the real numbers. Now you can see here, I have written, say normally I write 2 comma 3. This is interval form, how I'm writing interval. See, these intervals can be written in this form also, like this. This form, when I'm writing this form, it is known as set builder form. Set builder form. So it's very easy. Suppose I have this interval and I want to write it in set builder form. I can write it as this equals to any number x such that x is greater than 2 and less than 3. Okay, suppose I have this thing now. I have the interval. So all I'll just show you. This interval 2 comma 3, it can be written as, say, because this we are writing in set builder form. So inside set we always write inside curly braces. So inside curly braces I have to write this is equals to x such that x is greater than 2 and less than 3. Suppose I have this thing, this open interval, like this we have to write in set builder form. Now this is closed interval. Closed interval I will write this is equals to x such that x is greater than equals to 2 and less than equals to 3. So equality, because these points are included, so this inequality changes to greater than equals to and less than equals to. Now if I have this one closed 2 and open 3, this we can write as x such that x is greater than equals to 2 and less than 3, because 3 is not included, so x is less than 3. And this thing 2 open 3 closed we can write as x such that x is greater than 2 and less than equals to 3. So wherever closed interval is there, there you have to use this in inequality. So this is the concept which we will use while solving the questions of the exercise. Now let's start with the exercise. So exercise 1.3 I'm going to start now. So first question is make correct statement by filling the symbols. So symbols are there. This is one symbol and this is a symbol of subset. This is a symbol of subset, and we have another symbol on this subset. This line is there. This means not a subset. Not a subset. So these two symbols we just have to insert. See, in this form, I'll just explain you. You just have to imagine. See, although Venn diagrams we will be doing in next exercise, but you have to imagine this thing, then it will be very easy. If you have any bigger set and a smaller set is contained in that, that means this will always be a subset. If the set is not contained, that means it will not be a subset. So this thing you can imagine. Now, okay, let's start with the first one. So first set is given to us. This is 2, 3, 4, and here we just have to see 1, 2, 3, 4, 5. 2 is there here, 2 is there here also. 3 is there, 3 is there here also, 4 is also. So every element of first set is element of second set also, which means the first set is a subset of the second one. The smaller set will always be a subset. Then second one, A, B, C is the first one. Then here blank is there. B, C, D is the second. See, both the sets are now same. It also has three elements. It also has three elements. But A is present in first set, but A is not present in second set. That means, see, if single element is also not present, it will not be a subset. So this is not a subset. Fourth one, okay, so first we have done, second we have done. So first is a subset, second is not a subset. Then we'll do the next one. X is a student of class 11th of your school. and X is a student of your school. See, your school is a bigger thing. Your school is a bigger thing. So that means this imagination you have to do. Suppose this is your school, and in school so many classes are there. Okay, so in school this class 11th is also there, and all the students of class 11th are the students of school itself. So that means this set is a subset. So here itself I am writing. So X is a student of class 11th of yours. This set is a subset of when other set where X is a student of your school. So here I am marking. Then X is the fourth one. X is a circle in the plane. X is a circle in the same plane with radius 1 unit. So X is a circle in the plane. If we have any plane, suppose this is a plane. If X is any circle, it can be, see, this is one circle, this is one circle, this is one circle, because they have simply mentioned that X is a circle in the plane. But what is this? This is our first set. What is the second set? Second set, they are telling X is a circle in the same plane with radius 1 unit. So radius 1 unit, what does it mean? So circle will be like this. So any circle with radius 1 unit. So you can see here, first set will be a bigger set. So bigger set cannot be a subset of smaller set, because here only those circles are there whose radius is 1 unit. In second set, all circles are there with radius 1 unit. So this means first set is not a subset of second set. So this one not a subset. X is a triangle in a plane and X is a rectangle in the plane. So first set is X is a triangle in the plane, and second one is X is a rectangle in the plane. So let's see. See, if this is a plane, if this is a plane. So first set is a triangle. Anywhere it can be, because it's a set of triangles in a place. Okay, so second set is what? It's a rectangle. So both the sets are completely different. If both the sets are completely different, that means this is not a subset. So some similarity should be there, common thing should be there. So X is a triangle, the set will be like, it will have different types of triangle, can be any triangle, equilateral, isosceles, scalene, but rectangles will be different. So sets are entirely different. So which means it is not a subset. Now next one is, so next one we have, so fifth one we have done. Now sixth one, X such that X is an equilateral triangle plane. So X is an equilateral triangle in the plane, and second set is X is a triangle in the same plane. So X is equilateral triangle and X is, suppose this is a plane. So in plane here they have mentioned first it is equilateral triangle. So all the equilateral triangles. So A is the set of all equilateral triangles, because it's a set of X where X is equilateral triangle. So set B there's a simply some triangle. X is a triangle in the same plane. So triangle can be any triangle. It can be equilateral triangle also, can be scalene triangle, it can be isosceles triangle. So which means basically if you are seeing set A, so every element of set A is there in set B also, because it's a smaller set and this part is being covered here. Okay, so here it means this is a subset. I'll mark it. So this is a subset. X is an even natural number and X is an integer. So even natural number. So which are all even natural numbers? If you write, you can write few elements for an understanding. Even natural number, if I am writing, so this will be 2, big, all positive, because even natural number, then 4, then 6, then 8, so on it will be. Then X is an integer. If I am writing this set of integers, so this will be plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6, so and so on. So here you can see Positive 2 is there here also. Positive 4 is there in set A also. Positive 4 is there in set plus minus being positive as well as negative. So both. Instead of writing minus 4 and plus 4 separately, I am writing it as plus minus. Then 6 is also there, same way 8 will also be there. So set A is a smaller set and it's all the elements are contained in set B also, which means this set is a subset of this set. Okay, so let's do next question. So here true and false we have to just check, examine whether the following are true or false. So AB first set is given to us. AB is not a subset of B, C and A. So you just have to imagine same thing, bigger set should be a superset of smaller A, or in other words smaller set should be contained in the bigger set. So here A is there here also, B is there here also, and in other set also. So both the elements of first set is there in set second also, which means this should be a subset. But what they have mentioned here, it is not a subset, which means the first one is false because it should be a subset. Second is AE. AE is a subset of X such that X is a vowel in the English alphabet. So vowel means all the vowels we can write. So vowels are A, E, I, O, U. Now we can check. See, it was given to us in set builder form. I wrote it in roster form. So A is there in first set. A is there here also. E is there in first set and here also is there. So which means this set is a subset. So this is true. Second one is true. Then third one, 1, 2, 3 is first set, is a subset of 1, 3 and 5. So 1 is there in both the sets. 2 is not there in second set. So which means it should not be a subset, but they have mentioned it's a subset, which means it's a false statement. So next one, A set, singleton set is a subset of A, B, C. So yes, because A is there in this set and A is present in this set as well. So which means it's a subset. It's true. When any set has single element, it is known as singleton set. Okay, so next fourth one. Fourth one, it's true. Fifth one, they have mentioned set A. See, whenever any element is written inside the curly braces, that means this thing is representing a set. You have to remember in first exercise we have done representation of set. So there I have explained you. So set belongs to ABC. Here they have written this thing. So for set we don't use this word belongs to. For set we always use this word subset. So belongs to is used for, say this is used for elements of a set. And this is used for a subset. Now since this is a set, for set we can't use this. This means this is false. Sixth one, X such that X is an even natural number less than 6. So even natural number less than 6 we can write 2 even natural numbers less than 6. So 2 is even natural number which is less than 4. 2 and 4 they are the even natural numbers. Less than 6 is a subset of X is a natural number which divides 36. So X is a natural number which divides 36. 1, 2, 3, 4, then 6, 9, 12. So these are the numbers. Then 36. So these are the numbers which divide. So here we can see 2 is contained in both the sets and 4 is contained in both the sets. First set is a smaller set, which means this set is a subset of this set. Hence this is also true. So with this we have completed second question also. Let's do now next question. See, next question. Again, we just have to check which of the following statements are incorrect and why. So here again, you have to remember one concept. This symbol we always use for set because this is a symbol of subset, and this symbol we always use for element. Okay, and set is always written inside the curly braces. So once set A is given to us, set A is equals to, so elements are 1, 2, and one set is also an element of this set A, then 5. So if I have to write individually the elements of A, because for a better understanding I can write, so elements of A I am just writing. So elements of A simply I am writing not as a set. So 1 is an element of A, 2 is an element of A, then this set 3 comma 4 is an element of A, and 5 is an element of A. Now let's do this question. So first one is 3 comma 4. 3 comma 4 is a subset of A. See, I have written this in elements of A.